2-6a, rational functions. So, what is a rational function? A rational function is any function that appears in fraction form, such as f of x over g of x. An example of that would be x plus 1 over x plus 2. That is a rational function. This is also a rational function. X squared minus 9 over x plus 4. Alright, now we can't talk about rational functions without talking about asymptotes. For the general rule, asymptotes are dotted lines that graphs of equations approach but don't usually cross. Now, there's three kinds of asymptotes. You have horizontal, vertical, and slanted. Alright, vertical asymptotes will never get crossed. Horizontal might get crossed, and slanted might get crossed. We'll talk about slanted more in the next video. This video, we're just going to concentrate on horizontal and vertical. Vertical asymptotes. They're usually represented with vertical dotted lines. If you go back to the first slide here, oops, it disappeared. These dotted lines here would represent the asymptotes. All right. So they're usually represented with vertical dotted lines. Now, something special about vertical asymptotes is graphs will never, ever cross or touch vertical asymptotes. Why? There's only one way to get a vertical asymptote, and that is to divide by 0. So let's look at an example here. Our example, y equals 1 over x minus 1. It's normally okay for all x's except 1. And that is when x equals 1. So to solve for a vertical asymptote, you take your denominator, you set it equal to 0, and you know, so in our case it's x minus 1. Now we know that x minus 1 cannot equal 0. So we solve it for x, so x cannot equal 1. So what is this going to look like graphically? Here you go. 1 over x minus 1 represented graphically will look like this. We have our dotted line right here, which is our asymptote at x equals 1. Our graph comes from the right, goes up, it gets really close to it, but it'll never touch it. As well as here, coming from the left, it curves down, it'll approach it, it'll get really, really close to it, but it will never actually touch it. All right, so x equals 1 is a vertical asymptote. Now, I will abbreviate vertical asymptote as VA. All right, so anytime you see V dot A dot, just know that I'm talking about a vertical asymptote. All right. Here's an example. Let's find all the vertical asymptotes for y equals 3 over x squared plus x minus 6. So we know that vertical asymptotes can only happen when you divide by 0. Vertical asymptotes only happen if we divide by 0. All right. All right, they only happen if we divide by 0. So what we're going to do is we're going to take our denominator only, set it equal to 0, and solve for x. So we're going to have x squared plus x minus 6 equals 0. So we're going to have to factor this into two sets of parentheses. Since this is 1x, this is going to be x and x. Since since this is negative and this is positive, one of these is going to be positive, one of these is going to be negative. Now, our only factors of 6 are 1 and 6, but that's not going to give us a 1, and 2 and 3. Now, to tell which one's going to be bigger, since this is positive, the bigger number has to be positive. So 3 and 2. Set both of these equal to 0 and solve for x. You're going to get negative 3 and 2. So at negative 3 and 2, we're going to have vertical asymptotes. All right, so this graph is actually going to have 2 vertical asymptotes. Let's look at what this is going to look like graphically with my beautiful straight lines drawn by hand. All right, let's see. 1, 2, 1, 2, 3. So at x equals 2, we're going to have a dotted line. I'll change these to dotted in just a moment. All right, properties, dotted line, properties, dotted line. All right, so there's our 2 vertical asymptotes. And our graph from this side is going to look like this. Our graph from this side will look like this. And then here in the middle, we'll have a parabola. All right, so as you can see, we have 2 vertical asymptotes, one at x equals 2, one at x equals negative 3, and our graph will approach it on all 4 of these spots. It will approach our asymptote, but it will never, ever cross it. That's the important thing to remember with vertical asymptotes, is they'll never, ever get crossed. All right, now let's look at horizontal. Horizontal asymptotes, again, they're represented usually with horizontal dotted lines. Now, graphs can cross over it, but eventually settle down to it. All right. Now, so here's 2 examples. The first one, it can behave like a vertical asymptote and it'll get really, really close to it. But it can also cross it and eventually settle out to it. Like this might be a bungee jumper. You know, when they jump and they get to the bottom of the bungee, they're going to stretch it. All right. But if the bungee is, say, only 100 feet long, you know, this might stretch to 125 and then they'll bounce back up. They might only go down to 120 feet, bounce back up. 100 and, I don't know, 10, bounce back up. Eventually, they're going to quit bouncing and they're going to settle out to 100 feet. All right? They're going to settle out to the length of that bungee. And actually, they're a little, you know, they got a little weight to them. So they're actually going to be just a little bit longer than that bungee. So they won't actually get to the true 100 feet of that bungee cord. They might stretch it a foot, they might stretch it 6 inches, but just them hanging on it is going to stretch it a little. So this is a really good example because they'll be bouncing up and down, and then they'll come get closer and closer and closer, but they'll never get to the perfect length of that bungee because their weight is going to stretch that bungee a little bit. All right. Now, how do we find horizontal asymptotes? All right. To find any horizontal asymptotes, compare the degree of the numerator to the degree of the denominator. What do I mean by that? Right here, we have our function, x squared minus 3 over x plus 1. You look at the degrees. As you can see, the top is a second degree polynomial. The bottom is a first degree polynomial. So since the degree of the top is greater than the degree of the bottom, this function right here is going to have no horizontal asymptotes at all. No horizontal asymptotes because the degree of the top is larger than the degree of the bottom. Now, as you'll see in the next video, this may have a slant asymptote. All right, we'll have to check. Would have to check for that since the top is bigger and it doesn't have a horizontal. Would have to check to see if it had a slant. We'll get to that in the next video. The next case is if the top is less than the bottom. So what I did here is I just took this fraction and turned it upside down. So now the degree of the top is 1 and the degree, that's supposed to be an arrow, of the bottom is 2. So since the degree of the top is less than the degree of the bottom, this function is going to have a horizontal asymptote at y equals 0, or the x-axis. All right. Now, the third way you can get a horizontal asymptote is if you look at the top and bottom, and the top degree equals the bottom degree. As in this case, both the top and the bottom have a degree of 2. All right, 3x squared, 5x squared, plus 1 plus 2. So they both have a degree of 2. So your horizontal asymptote is the line y equals a over b, where a is what does LC stand for again? The leading coefficient of the numerator. So the leading coefficient of our numerator, remember, is you find your degree, and it's the coefficient on that same variable. So in this case, this would equal 3. And then b is the leading coefficient of the denominator. So it would be 5. So our vertical asymptote would be, sorry, I said vertical, I mean horizontal. Our horizontal asymptote would be y equals 3 over 5. So when the degrees are the same, it's simply the leading coefficients of the top and the bottom divided by each other. All right, so this would have at the line y equals 3/5 would be our horizontal asymptote. All right, now make sure you know these, make sure you remember these. All right, now I went ahead and gave you the ticket in the door because I don't believe this was too hard of a lesson. This one might be a little challenging, but you can probably get it. If not, just ask me in class tomorrow. So what I want you to do is I want you to find the horizontal asymptotes for the following functions. Number one is 7x cubed minus 4 over 2x squared minus 9x cubed. 2 is 4 plus x over 7x squared minus 1. And 3 is 2x plus 1 over the square root of 3x squared minus 1. Now, the reason I didn't give you any vertical asymptotes is because for the vertical asymptotes, you just simply set the bottom equal to 0 and solve for x. All right, it's pretty simple. I think y'all can handle that. We've been doing that. When you find ways that functions blow up, you can't divide by 0. So that's why I only did horizontal asymptotes for y'all today for your ticket in the door. So make sure you find the horizontal asymptotes for these 3 functions. Please don't use a graphing calculator and just graph them and estimate them and write them down. Actually do them out mathematically and tell me what the vertical asymptotes for these 3 functions are. If you want to use a graphing calculator to check your work, you're more than welcome. But please don't use it to do your work. All right, see you tomorrow.